Hello, my dear students. I am Dr. Dharmendra Tyagi, Associate Professor, Mechanical Engineering Department, SIRT, the SAGE Group, Bhopal. Today, we are going to discuss about the flywheel. Now, the contents. This lecture consists of the different topics. First, we'll discuss about the coefficient of fluctuation of energy, then maximum fluctuation of speed, then coefficient of fluctuation of speed, and function of a flywheel, and the energy stored in a flywheel. We'll start from the coefficient of fluctuation of energy. So, what is the definition of the coefficient of fluctuation of energy? It is the ratio of the maximum fluctuation of energy to the work done per cycle. And mathematically, we can write it here, the maximum fluctuation of energy divided by the work done per cycle. It is represented by CE. Then the maximum fluctuation of energy, that is equals to delta E. Or this is the W that is work done per cycle. We can calculate the maximum fluctuation of energy by the determination of maximum fluctuation of energy in the flywheel. And also, we can calculate this delta E, maximum fluctuation of energy, in the derivation of the energy stored in the flywheel. We will discuss in this lecture at the last. And first of all, we have to calculate the value of work done per cycle. So now, the work done per cycle, that is equals to T mean into theta. What is the T mean? That is the mean torque. And theta is the angle turned in one revolution. So that value of the theta, that is equals to 2 pi in case of the steam engine and 2-stroke IC engine, and 4 pi in case of the 4-stroke IC engine. That means the one revolution complete in 2 pi, that is 360 degree, that in case of the steam engine and 2-stroke IC engine, and the one revolution is completed in case of the in 4 pi in case of 4-stroke IC engine. Then how we can calculate the value of T mean? So we know that the T mean is equals to P upon omega, or we can say that the P is equals to T mean into omega, or 2 pi and T mean upon 60. And we can also determine the work done per cycle by this formula, P into 60 upon small n. And small n is the number of working stroke per minute. The value of small n in case of the steam engine and 2-stroke IC engine is capital N. And in case of the 4-stroke IC engine, it is N by 2. So this is the coefficient of fluctuation of energy, and the work done, how we can calculate the work done for calculating the coefficient of fluctuation of energy. Now, the maximum fluctuation of speed. It is the difference between the maximum and minimum speeds during a cycle is called maximum fluctuation of speed. For example, the maximum speed is N1 and minimum speed is N2, then the maximum fluctuation of speed is equals to N1 minus N2. Now, the coefficient of fluctuation of speed, that means it is the ratio of maximum fluctuation of speed to the mean speed, is called the coefficient of fluctuation of speed. So, for example, let we consider the N1 and N2, that is equals to maximum and minimum speeds in RPM during a cycle, and N is the mean speed in a cycle. Then the coefficient, the mean speed is equals to N1 plus N2 by 2. And the coefficient of fluctuation of speed, that is equals to N1 minus N2 upon N, and this is represented by CS. And it can also be written as in case of the angular speeds, in terms of angular speeds, that means omega 1 minus omega 2 upon omega, or in linear velocity v1 minus k v2 upon v, that is equals to coefficient of fluctuation of speed. And the coefficient of fluctuation of speed is a limiting factor in the design of the flywheel. It varies depending upon the nature of the service to which the flywheel is employed. Now, the function of the flywheel. What is the function of a flywheel? That means how the flywheel is working. That means flywheel used in machines serves as a reservoir. which stores the energy during the period when the supply of energy is more than the requirement, and releases it during the period when the requirement of the energy is more than the supply. And the flywheel controls the speed variations caused by the fluctuation of the engine turning movement during each cycle of operation. Now, we have to calculate the energy stored in the flywheel. That means the maximum fluctuation of energy, that is delta E. Now, the flywheel is shown in this figure. Here you can see this is the rim, this is the hub, and these are the arms and the radius of this rim. And here when the flywheel absorbs the energy, its speed increases. And when it gives up the energy, its speed decreases. Let small m is equals to mass of the flywheel, k radius of gyration of the flywheel, radius of gyration of the flywheel, I moment of inertia of the flywheel about its axis of rotation in kg meter square, that is equals to mk square. And the other terms we have already discussed, n1 and n2 maximum and minimum speeds, omega 1, omega 2 maximum minimum angular speeds, and mean speed, omega mean angular speed, and Cs is the coefficient of fluctuation of speed. Now we know that the mean kinetic energy of the flywheel, that E is equals to half I omega square, and I that is equals to mk square. Now the maximum fluctuation of energy, we know that according to the definition, maximum fluctuation of energy delta E, that is equals to maximum energy minus k minimum energy, or we can say that n1 minus n2, but here it in the form of kinetic energy. So maximum kinetic energy minus k minimum kinetic energy, and the kinetic energy, that is equals to half I omega square, but in maximum, that it means we consider the speed is maximum and I is constant. So here you can write it here, delta E is equals to half I omega 1 square minus half I omega 2. This is the maximum speed, this is the minimum speed. I is constant for both. And it can also be written like this, half I omega 1 square minus k omega 2 square. We can open it, a square minus k b square. That means omega 1 plus omega 2 and omega 1 minus omega 2. So this is omega 1 plus omega 2 and omega 1 minus k omega 2. And here you can see, this is the, what is this? Omega 1 plus omega 2 divided by 2. What is this? This is the mean speed. This is the mean speed. And we can write it here, that is omega. Mean speed is omega. So I omega into omega 1 minus k omega 2. So now we can multiply it by the omega and divided by the omega. So then there's no change in the equation. Here you can see the multiplied by the omega, that means omega is omega square and divided by omega. But here you can see that, what is this? Omega 1 minus omega 2 upon omega. This is the coefficient of fluctuation of speed, that is represented by Cs. So I omega square Cs, that is the delta E. That means maximum fluctuation of energy delta E, or we can say that energy stored in the flywheel, that is equals to mk square omega square Cs, or delta E is equals to 2ECS. So this is the energy stored in the flywheel. Thank you.